So today we are going to discuss about exponential Fourier series. But before going to the exponential Fourier series, we would like to prove that the complex exponential signals are orthogonal functions. As we have learned in the previous chapter about orthogonal function, so in order to say that two signals are orthogonal to each other, the integration of their product should be equal to 0. Okay, so for this, let us consider two complex exponential signals given as x1 of t is equal to e to the power jn omega 0 t, and the second signal x2 of t is equal to e to the power jm omega 0 t. All right, so let us consider the interval. Let the interval be let the interval be t0 to t0 plus capital T. Capital T is the period, a fundamental period of the given signal. So within this interval, to prove that whether it is orthogonal or not, okay, or we can also say that this limit be t0 to t0 plus capital T is given by 2 pi by omega naught, where omega naught is the fundamental frequency. Okay, so now in order to say whether it is a orthogonal signal or not, we need to find out integral, that if the integral value, that is I am taking I, which is the integration of t0 to t0 plus 2 pi by omega naught integration of x1 t into x2 star t dt should be equal to 0, where the x2 star of t is the complex conjugate of signal x2 of t. Whenever there is a complex conjugate of exponential signal, their sign will change exponential. When it is plus j m omega 0 t, the conjugate will become minus j m omega 0 t. Okay, so let me write this in the next page. So here, what will be our x1? X1 will be same what we have assumed, that is e to the power j n omega 0 t. And what is x2? Conjugate star of t, which is equal to exponential minus m omega 0 t. Now the integration can be found out by integrating t0 to t0 plus 2 pi by omega 0. x1 of t is e to the power j n omega 0 t, and x2 of t is e to the power minus j m omega 0 t dt. Now, since when you multiply exponential functions, their power will be added. So the next step will be integration t naught to t naught plus 2 pi by omega naught, which is equals to e to the power j n minus m omega 0 t dt. Now we can do the integration of exponential function. The next page, that is, it is equals to integration of exponential function is e to the power j n minus m omega 0 t upon n minus m j n minus m omega 0, and we can add the limit from t0 to t0 plus 2 pi by omega naught. So if you add the limit, denominator will take the same jn minus m omega 0. Numerator we can add as e to the power j n minus m omega 0 into, in place of t you can add first t naught plus 2 pi by t omega 0, okay, minus e to the power, the second limit is t naught, so j n minus m omega 0 t0. In place of t, we substituted t0. Okay, evaluating this now in the next step, that here there is a plus sign, so we can split the plus sign exponential into two terms by multiplication of two exponential terms. Okay, so first term will be j n minus m omega 0 t naught. The second term will be j n minus 1 omega 0 into 2 pi by omega 0. So let us do that in the next step. So this would be equal to exponential j n minus m omega 0 t0 and exponential j n minus m omega 0 into 2 pi by omega 0. So the omega 0 will get cancelled, okay, and that remains is only 2 pi. So minus, there was already exponential j n minus m omega 0 t0. Okay, divided by whole j n minus m omega 0. So this was going to become, since e to the power j n minus m 2 pi is always 1, so this value of e to the power n minus 1 n minus m 2 pi is always 1, because e to the power j 2 pi and any multiple of 2 pi is always 1. Okay, so that is going to be same, that e to the power n minus m omega 0 t0 minus e to the power j n minus m omega 0 t0. So both the term became same. In the numerator, denominator is whatever it was before. Now since numerator both are same, the subtraction will be 0. So hence we had found that the complex exponential signals are always orthogonal functions, and they are because their integral of exponential functions with their complex conjugate is always 0. Thank you all. We'll continue in the next class.